Hello and welcome back to Anton Math. Now in this video we're going to take what we've learned so far about vectors and we're going to take a vector and we're actually going to break it down into its basic components, its horizontal and vertical components, and this is going to help us do some arithmetic on these vectors much more easily. So first let's take a look at a vector in the xy plane. So let's say I have some vector out here in space. We'll say this is my vector v. And let's say my initial point of this vector is at some coordinate x1, y1. And my terminal point of this vector is at the point x2, y2. Now I want to break up this vector. Let's say I draw a line down this way, horizontally from my terminal point, vertically from my terminal point, and I draw this horizontal dotted line from my initial point. Now what we get here is we're going to get a right triangle. So if I call this line down here A, let's say it has length A, and let's say this vertical line has length B, well in this case my A is going to be equal to my coordinate at my terminal point, my x coordinate x2, minus my x coordinate at my initial point x1, isn't it? What I'm doing is I'm taking my total x2 and I'm subtracting from that x1, and the difference here then is going to be what we are labeling as A. And we can do the same thing for B. B is going to be my y value at my terminal point minus my y value at my initial point. This is the total distance between B and this corner of my triangle, between my terminal point and this corner of my triangle. Now remember that it doesn't matter where we draw the vector. I could draw this vector over here. I could call this my vector v. I could have my vector v down here. In all cases, we get the same A and B. So these points for the initial point and terminal point are going to be different, but this horizontal and vertical distance, A and B, are going to be the same. And I know my vectors look a little bit off, but let's just say these are all the vector v. Now typically, to make this easier, we choose to draw the vector v coming from the origin as the initial point. Right, if I draw my vector v here with the origin as my initial point, then my terminal point is actually going to be AB, isn't it? Where A is this horizontal distance and B is the vertical distance when I fill in and draw this right triangle. So this is going to help us later, but first, for any vector, no matter what my initial point and terminal point are, we can use this to talk about what we call the component form of a vector. So a vector v, if a vector v, is represented in the plane with initial point x1, y1 and terminal point x2, y2, then the component form of the vector, we use the first component, means the actual horizontal distance traveled by the vector. So we saw that's going to be A, or x2 minus x1. And this second component of the vector is the vertical distance traveled by the vector. So that's going to be my B, or y2 minus y1. So in the diagrams we have above, we could just write A, B here. So this is my A is my total horizontal distance traveled, B is my total vertical distance traveled. So let's take a look at some examples we might get using this component form of these vectors. So first, let's say we're given this problem: express the vector with initial point 3, 2 and terminal point 8, 9 in component form. So let's say we call this vector v. Now by what we had before, the component form of this vector v is going to be, if I break this up into x2 minus x1, where x2 is the x value in my terminal point. So here my horizontal component is 8 minus 3. And I'm going to look at y2 minus y1, where y2 comes from my terminal point, y1 comes from my initial point, so that's 9 minus 2. And we get that the component form of this vector is going to be 5, 7. That means that as we go from the initial point to the terminal point, we've traveled a horizontal distance of 5 units and a vertical distance of 7 units. Now let's take a look at this second problem. I'll go ahead and get this out of the way. Sketch the vector u, which in component form is 4, negative 3, with initial point 4, 3, and find the terminal point. Okay, so before we start sketching, let's go ahead and make a plane. I'm only really going to need the positive portion, and in particular I need a large quadrant 1 here, we'll see in a moment. Let's go ahead and mark out some of these points. Let's say this is 2, 4, 6, 8, and let's say this is 1, let's do 2. Let's say this is 2, 4. Now before we draw this in, I could do a little calculation here. I know that my vector u, this is equal to x2 minus x1, but here I'm given x1. x1, remember, is the x part of my initial point. So this is x2 minus 4, y2 minus y1, and y1 we're given here from my initial point. So if we find x2, y2, we've found the terminal point, haven't we? So my vector, we already have the component form, is 4, negative 3. So that means that 4 is equal to x2 minus 4, which gives us that x2 is going to be equal to 8. And negative 3 is equal to y2 minus 3. So this gives me that my y2 is equal to 0. So I have this initial point of my vector is 4, 3, so that's going to be about right here. And my terminal point of this vector we found with just some arithmetic over here is going to be 8, 0. So that's right here. So my vector u looks a little bit something like this. It's starting at 4, 3, and it's going down to 8, 0. We'll say this is my vector u. Okay, so that's how we do some of these problems with component form. Now before we finish up this video, there's one more topic I want to talk about, and this is coming back to the magnitude of a vector. So let's come back here. Let's take a look. If we draw a vector in the xy plane where my initial point is at the origin, well, we know that if this is vector v, then this total distance of the vector, we called this the magnitude of the vector. That's the length of this line segment that we draw. And we can draw this vector anywhere we want. So we can always choose to draw it at the origin. But even looking at all of these other triangles in space, just by using Pythagorean's theorem, we see that we can calculate out v in terms of the components a and b, can't we? So let's document this result. The magnitude of a vector v in component form ab is the square root of a squared plus b squared. And that's just coming from these triangles here. If I look at this triangle, I know that the total length of the vector itself, v, is going to be the square root of a squared plus b squared. All right, we're used to seeing stuff like this. If this were polar, if we were just looking at some point in polar form, we would call this magnitude r, wouldn't we? And that's not what's going on here, but just to relate it to some things we've already done, we can use this formula for the magnitude. So if we have the vector in component form, the magnitude of the vector is the same as the formula for finding the modulus of a complex number a plus bi, isn't it? We still have a squared plus b squared under that square root. Well, let's take a look at some examples so that we can really make sure that we understand what's going on here. So let's say we're asked to find the magnitude of these vectors, u and v. So all we're going to do is we say, well, the magnitude of u, that's equal to the square root of a squared plus b squared. Here my a is 3, so I have 3 squared. My b is negative 4. We put plus negative 4 squared. So this is going to be the square root of 9 plus 16, which gives us the square root of 25, or 5. Okay, we found the magnitude of u. Easy peasy. The magnitude of v will do something similar. This again is just the square root of a squared plus b squared. Here my a is 3/5. So I'm going to look at 3/5 squared plus, and my b is 4/5. We have 4/5 squared. So this is going to be the square root. 3/5 squared is 9 over 25. 4/5 squared is 16 over 25. So this is going to be the square root of 25 over 25, which of course is just the square root of 1, or 1. So the magnitude of u is 5, and the magnitude of v is 1. All right, that's it for this video. Now we're going to take, in the next video, we're going to take these component forms and start to use addition, subtraction, and multiplication by a scalar on these component forms, and we'll be able to start doing some algebra with these vectors. So we'll see you there.